Hi, my Gator friends. Yesterday, we worked on comparing fractions using visual models, and our denominators were always alike. Today, we're going to be comparing fractions on a number line, and we do this by reasoning about their distance from zero. So I just want to build some background with you on something that you already understand really well, and that is a number line. So if you'll bear with me here, I'm going to draw a number line in here. You do not have to do this, but I'm going to draw a number line right here. And these are number lines that you guys are just used to seeing all the time. You've been working with them since you were in like kindergarten, even before that. And so on that number line, I'm going to start with 0 right here and put some divisions here. This is just a regular old number line. Okay, let me label these so you can see what I'm talking about with my number line. So this is just going to be 0. This is going to be 1. This is going to be 2. This is going to be 3. And this is going to be 4. So I'm starting with the real simple concept of numbers on a number line. So when we compare these numbers, we can say that 1 is less than 4. How do we know that? Well, you know that in your mind because you've been working with those numbers for so long. But we also know it because 1 is only this far from 0. And 4 is, whoa, 4 is this far from 0. I can't even draw the line. So that's how we know 1 is less than 4. If we look at them on a number line, 1 is closer to 0, 4 is further away from 0. Guess what? It works the same way with fractions too. So the further away a fraction is from 0, the greater it is. The closer it is to 0, the smaller it is, just like with any other numbers you've used on a number line so far. So let's get started comparing fractions on a number line. I'm going to type in our learning target here. So we're going to say we can compare fractions on a number line. And we're going to say by reasoning about their distance from 0. And that's really the most important thing here, is knowing that we can tell how big they are because of their distance from 0. Get that out of the way for us. Okay, so we have two number lines here, and how about that? We're going to compare 3/4 and 2/4. The directions say place a dot to show the location of the fraction on the number line, then write less than, greater than, or equal to compare the fractions. So the first one is 3/4. What do you notice about both of these fractions? They do have like denominators, which is what we did a little bit of yesterday. Okay, so I'm going to go ahead and I'm going to find 3/4. So this is 1, 2, 3, 4. So I want to make sure I do have 4s. 3/4 would be 1/4, 2/4, 3/4 would be right here. I'm going to put a dot there. And then down here, I have to find 2/4 on this number line. 0/4, 1/4, 2/4. 2/4 would be right here. And now when I go to compare those, well, 3/4 is this far from 0. And 2/4 is this far from 0. So which one is bigger? 3/4 is because it's a greater distance from 0. So we would write in our comparison, 3/4 is less than, or I'm sorry, excuse me. Undo that real quick. 3/4 is greater than 2/4. I apologize, boys and girls. All right, let's go on to the next one. Again, we're comparing 4/10 and 7/10. So again, my denominators are the same. And yesterday we learned when the denominators are the same, really all you've got to do is compare the numerators. But we're going to use these visual models of number lines to help us. So 4/10, I want to count and make sure they divided this number line correctly into tenths. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I do have 10 equal parts. And now I want to find 4/10 on there. So this would be 0/10, 1/10, 2/10, 3/10, 4/10. I'm going to put my dot there. All right. Down here, I want to find 7/10. So I'll start again at 0/10, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. And if it helps you, you can go ahead and write the fractions underneath here. That might be a good idea. So we'll write 4/10 here. I really like to make my visuals as clear as possible. And we'll write 7/10 here. And now when I go to compare these, what do we say about 4/10 in comparison to 7/10? Well, 4/10 is this far from 0. 7/10 is this far from 0. So 4/10 is definitely closer to 0. So 4/10 would be less than 7/10. And if we look at this, we know 4 is less than 7. So that makes sense that 4/10 would be less than 7/10 only because our denominators are the same in both fractions. We're counting tenths. All right, let's go on to our next example. 8 equal parts makes eighths. Go ahead and count those and make sure you have 8 equal parts. We do have 8 equal parts. 8 eighths, you know what? I'm going to just go right out here to 1 because I know that 1 whole is 8 eighths. I remember that 8 divided by 8 equals 1. And I know if we have 8 eighths, we are at the whole number 1. I'm going to box this because it's a special fraction. That's where 8 eighths will go. Down here, I'm comparing that to 6 eighths. So I'm going to start and count at 0 eighths, 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths is right here. And I'm going to write that fraction here, 6 eighths. And now again, I'm going to compare them. My denominator is the same. When I look at this too from how far those fractions are from 0 on the number line, this one is all the way from here. That's pretty far. That's about as far from 0 as you can get on that number line. And here, 6 eighths is only this far from 0. So 8 eighths is definitely further away from 0. So we'd say 8 eighths is greater than 6 eighths. We can also look at those numerators. Our denominators are exactly the same. They're both eighths. We're comparing eighths. So 8 eighths would be greater than 6 eighths because 8 is greater than 6 in this case. All right, let's go to the last one. This is different. Can you tell what's different about this set of fractions? That's right. Our denominators are not the same in this example. So we're going to be comparing 1/4 to 1/5. And if I look at my first number line, it is indeed divided into 4 equal parts or fourths. I will find 1/4 on here by counting 0 fourths, 1/4, and I'm going to put my dot on the line, and I'm going to label that 1/4. My next fraction is 1/5, so I'm going to count my number line and make sure they drew it accurately. 1, 2, 3, 4, 5 equal parts makes fifths. This would be 0 fifths. This would be 1/5 right here, just one tick mark away from 0. That's 1/5. Now this is close. 1/4 is this far from 0. 1/5 is this far from 0. Which one is closer to 0? 1/5. So that means 1/5 is smaller. 1/4 is further away from 0, so that means 1/4 is bigger. So when I come over here to make my comparison, I'll say 1/4 is greater than 1/5. You're going to say, well, wait a minute. 1 and 1 are the same numerator. They are. But fourths are bigger than fifths. So we're not comparing the same denominator anymore. We're not comparing the same unit anymore. We're comparing fourths, which are bigger, to fifths, which are smaller because there's more pieces. So it is very different, boys and girls, when you're comparing fractions that do not have the same denominator. Then you really have to focus on the denominator and say, how big are those pieces anyways? All right. You have another sheet to practice this skill independently. Please refer back to the YouTube video if you need to. And I will put a key out on my teacher webpage so you can check your work and make sure you're practicing correctly. All right, boys and girls, thank you for joining me. Take care, and we'll see you soon.